Okay, so today our homework was on optimization problems. Optimization problems. And optimization is all about finding maximums and finding minimums and proving that those are maximums or minimums. Any way you do that is fine. The most common way is to find the first derivative, is to find f prime, and find where f prime is 0. Where is f prime equal to 0? It's going to be equal to 0 at those 2 points. And then you need to prove that it's a maximum or minimum, and the way you do that is either by looking at points on either side of f prime. So that's one way to do it, is to look at f prime on a number line and show that where you were 0, you went from either positive to negative or negative to positive. And the second way to do it is to look at the second derivative. The second derivative is easy to take. You look at the second derivative, and if it was a positive second derivative, you were concave up, and therefore you were a min. And if your second derivative was negative, then you were concave down, and you were a maximum. So the green step always happens. That says man, not max. The green step always happens. Then you can choose either of the second steps to prove that you're max or min. So let's take a look at the problem that was assigned for homework last night, and it was the divided stock pen problem. Suppose you're building a rectangular stock pen, like given in the picture, using 600 feet of fencing. So first I'm going to draw my picture. It looks like that. I'm going to label my sides. X, 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 Y, Y, Y. And they tell me I have 600 feet of fencing. That's my condition I'm going to use later. And the key is to keep an eye on the units. It says 600 feet of fencing. You use part of this fencing to build a fence across the middle of the rectangle. Find the length and width of the rectangle that gives the maximum area. So I want to maximize area. And the last problem I didn't do that. I maximized perimeter. So I want to maximize area. So the first step is to come up with an equation for area. The equation for area is area equals x times y. Oh, is it equal x times y according to my picture? No, it doesn't. My area equals, according to my picture, 2x times y. Now, you can label your picture any way you want. If you want to put 1x, it doesn't make a difference. However you label it, as long as your area equation matches on up, you're going to be in good shape. So that's the area I want to maximize. Now I've got the condition. 600 feet is the perimeter. So the question is, how much perimeter do I have? Well, I'm going to add them on up. 1, 2, 3, 4. I've got 4 x's. 4x plus 3y equals bloop, 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 600. So whether I drew 2 x's here or 1x, I'd have to account for it somewhere in the equation. I'm going to leave it just like this. It's fine. So now what I have to do is get my condition that's true into my area equation to make one variable go away. I don't care which variable I make go away. I'm going to make the x go away. I'm going to make the x go away. So first thing I'm going to do is I'm going to subtract 4x from each side. And I've got 3y equals 600 minus 4x. And then I'm going to divide by 3. And I've got y equals, what's 600 divided by 3? That's going to be, let's look at that, 200? Thanks, Matt. 200 minus 4/3 x. So I now have my condition to put in the equation. So a is going to be, I'm going to replace the y in the equation. So a is going to be equal to 2 times x times 200 minus 4/3 x. So I have that equation there. Now I could do this all in the calculator, but you know I'm not going to do it that way. I'm going to simplify this equation. I'm going to distribute the 2x to each of the terms here. So I've got a equals 400x minus, so when I distributed the terms, I got a equals 400x minus 8 over 3x squared. At this point, if you want, you could graph it and find a max or min, but you still need to prove that it was a max or min. So what I've done is I have a right here. I'm going to find a prime. A prime is going to be 400 minus 16 over 3 x. That correct? That's correct. Correct. And just for fun, I'm going to find a double prime to tell me the concavity. I'll save that for later. Is going to be negative 16 over 3. Now, because I found the concavity, this is always, graph is always concave down. How do I know it's always concave down, Carrie Ann? That's right. Because of the minus sign, I know it's always concave down. So when do we have turning points? When the derivative is either 0 or undefined. In this case, we're going to set this equal to 0. So 0 equals 400 minus 16 over 3x. So I'm going to move 16 over 3x to the other side. I'm going to work sideways just for a minute so I have enough room here. So it's going to be 16 over 3x equals 400. I want to get rid of the 16 over 3x. I'm going to multiply both sides by 3 over 16. Because that's going to do the same thing for me. I'm going to turn this into a fraction for a second. 3 over 16. I know this goes in 4 times. This becomes 100. So x is equal to 300 over 4. And that's a good answer for x. But am I done? I might be done if that's all they wanted to me. They want me to find the length and width that give the maximum total area. I found x being 300. I'm going to write this on this next page. X equals 300 over 4. But now I've got to figure out what y is going to be. So to figure out what y is going to be, I'm going to look back to my original equation. And here it is. Y is 200 minus 4/3 x. Y is equal to 200 minus 4 over 3 x. So I'll substitute in the x for that value. Y equals 200 minus 4/3 times 300 over 4. Blip, plop, bloop, bloop, 1. So y equals 200 minus 100. Y is equal to 100. If I get anything wrong on the math here, you can tell me. And then the area is going to be, for this one, it's going to be 2x times y. So the area would be equal to 2 times 300 over 4 times 100. I can cancel. This goes in here. 4 goes in 125 times. 25 times 2 is 50. 50 times 300 is going to be 1, 2, 3. 50 times 3. Am I off a 0? I don't think I'm off a 0. That is going to be our maximized area. A lot of steps to find that maximized area, but I did them one at a time. First I found the x, then I found the y, and then I found the area. Multiple ways to answer it, whichever way you choose to do, just fine by me.